Welcome back, chemistry fans. Let me turn on light so I'm not so dark and evil looking. Okay, we're going to do your homework. Unit 4, topic 3. So let's jump right into it. We're going to talk about nuclear chemistry. All right, here we go. So the first question, it's got an unbalanced chemical or nuclear reaction. What we got to go and do is we've got to go and fill in the blanks so that we can fill in, the information that is missing on this element. We need to understand that uranium is element 92 and thorium is element number 90. Okay, how do I verify that? I go and look at a periodic table, boom. And I look down here at the bottom, uranium is 92 and thorium is 90, right below it down here in orange at the very bottom. Okay, that now set aside. What I got to do next is I've got to try and figure out, okay, well, what is missing over here? So on the left side, I have 92. On the right side, I have 90. So that means I'm missing 2. On the top, I've got 235 and I've got 231. So that means I'm missing a 4 because 4 plus 231 gives me 235. 90 plus 2 gives me 92. So I've got a 4 and a 2. Now, what you could assume from that is that element number 2 is in fact helium and it has a mass number of 4. Now, what that actually is an alpha particle. An alpha particle is a helium nucleus. It has no electrons. All right, number 2. Write the completed nuclear reaction for polonium PO194 that undergoes an alpha decay. That means it produces an alpha particle. Well, we got to first go and figure out what in the world is the atomic number for polonium. So polonium, and this is a little bit big here for us to find it. It's on the very bottom down here. It's 84 in green. All right, so I'm going to take that 84 and I'm going to fill it in for the atomic number for polonium. Now, it's the exact same operation that we had before, only this time we're given the particle. We want to figure out the element. So I need to figure out what number plus 4 equals 194. Well, that's 190. And then what number plus 2 equals 84? Well, that would be 82. So now I'm going to go back to the periodic table and figure out what is element number 82. Now, element number 82, right beside polonium, polonium was 84, is lead at 82. So that's where we are at. So I've got lead as the missing element. So that's my answer. All right, now comes a half-life problem. In this half-life problem, what we are doing is setting up a table, and it always starts the same way: time and amount. So the time always starts at 0. The amount, it says it starts with 18 grams, I believe, is what this problem says. Let me move it out of the way a little bit. Yeah, 18 grams is how much you start with, and then it ends with 0.01. Well, we don't know how long. Oh, sorry, we do. 8,340 years is the half-life. So that's 1 half-life. 2 half-lives. We keep splitting the amount in half. So 18 becomes 9, becomes 4.5, which then if I cut that in half would be 2.25. And you're saying, well, how do you know to keep cutting it in half? Because it tells us that it wants it to get to 0.01. Well, that's a long time away. So let's see if we can get there. 0.5625, divide that in half. You get 0.28125, divide it in half, and you get 0.140625. Oh my goodness, we're almost there. 0.07, you divide it in half, and it has less than 0.01. Well, we're still not there. Geez. 0.035 divided by 1, less than. So we're going to have to do it one more time. And there it is, 0.00879 before we finally get below. Now, For this to occur, we have to understand how many half-lives it took us to get to that point. 9, 10. It took 11 half-lives for us to get below the amount that was started with there. Now, each one of those half-lives is 8,340 years. So 8,340 times 11 is 91,740 years. So the question is, how long? That's your answer, 91,740. Thank you very much for your time. I will talk with you again soon. Farewell. Bye-bye.